So before we get into the nitty-gritty of solving these equations by factoring, you're going to get more practice factoring today. But before we get into that, we're going to talk a little bit about what the solutions to these equations mean, and what they mean graphically and when we graph. So we're going to use the graphing calculators, and I just want to show how we can solve these equations by graphing, because that will come up especially later on when we're into the modeling stage of this. And to solve something by graphing, the solution to this system are the points of intersection where the graph of the left side, so if we put the left side into y sub 1 on our graphing calculator, and we know that that's a parabola now, y-intercept is 6, and so on, it opens up, and where that crosses the line y equals 0, which hopefully you know is a horizontal line, basically the x-axis. Okay, so if we take a look on our calculator, and in y sub 1, when we go to y equals, we're going to clear out anything that's in there. And in y sub 1, we're going to just enter the left side of that, which was x squared x squared minus 5x plus 6. And then in y sub 2, we're going to enter the right side, which was just y equals 0. In y sub 2, y equals 0. So we're going to graph this on the standard window just to see if we can see where they will cross. So we're going to hit zoom 6. That gets us to the standard window. And there's the parabola, that first graph. And then the second graph is that horizontal line, y equals 0. Now it looks to me like these two cross in two different places. At positive 2 and 3. That's where it looks to me. We can find out for sure by calculating. So we're going to hit second trace, and we're going to calculate an intersection. Okay. Is the first curve one that we want to find intersection of? Yes. Second curve, y equals 0? Yes. And then again, it's going to ask me for a guess, which really doesn't matter. So, yeah, that first intersection is the point 2, 0. So x equals 2 would be a solution to this equation. That's what it means graphically. Now, I think there's a second intersection there, right about there. So what I'm going to do is calculate that second intersection. Another intersection. It's going to ask first curve, yes. Second curve, yes. Sorry, I double-clicked somewhere in there. So I'm going to hit second, trace again, calculate the intersection. First curve, yes. Second curve, yes. And then it's going to ask me for a guess. And for this guess, I'm going to scroll to the right so I'm closer to that other intersection. Notice how my cursor now is flashing closer to that second intersection. Then I'm going to hit enter. When that's close, now we find that the third intersection is 3, 0. So our two solutions we would expect to have is 2, 0. Okay, so if we go back to the graph, so x equals 2 and 3. You may want to just write that down. In the next video, we're going to solve this by factoring algebraically and see if we get those same things. All right, now in B, we're going to put the left side in y sub 1 and right side into y sub 2. Again, this is another parabola, and the right side is a horizontal line except at -12 instead of at 0. So we're going to go back to our calculator and go back to y sub 1, and in that first one we're going to put x squared minus 7x. And then in our second one we're going to put -12. Now, what we're going to have to do here is, it's not going to, the calculator's not going to like that double subtraction. I don't know, so I'm just going to delete one of those. I was only supposed to delete one of those. So we'll go -7x. And again, so x squared minus, again we squared it twice. I'm just going to clear that again and try to start from the beginning. X squared minus 7x. Alright, so now we're going to have to adjust the window a little bit and get this y minimum down below -12. So I'm going to go to maybe y min of -15. -115 is way too far. So I'm going to delete one of those ones, and I'm also going to delete one of those negative symbols. Okay, so now I'm going to hit graph. So there's the parabola, and there is -12. And again, it looks like we may have a couple of different solutions there. So we're going to calculate those. So we're going to second trace. Better make sure I hit the second and then trace. And we're going to calculate the intersection again. First curve, yes. Second curve, yes. And then I hit yes, intersection, x equals 3. And I think that we might have another one here, so I'm going to check that out. I'm going to calculate another intersection. First curve, yes. Second curve, yes. And for my guess, I'm going to right arrow so I move closer to the second one. And my second solution is x equals 4. So my two solutions then are 3 and 4. So x equals 3 and 4. You may want to just write those down, and just to confirm later that once we factor, we'll have those same solutions. We're going to look at one more, a little bit tougher probably. Let's look at D on this one. Again, we have a parabola, and we want to see where that intersects this line. So in that first, we're going to put 4x squared minus 14x plus 7. just a quick check, make sure I have that right. Back here, 4x squared minus 14x plus 7, good. And in the second one, I'm going to put the 4 minus x. So we're going to have 4 minus x. In the second one, I see I got 2 4's there. So I'm going to delete one of those 4's. Okay, and just to get an idea, I'm going to zoom 6 this just to see if I can see any intersections when I zoom 6 this. So there's the first parabola, and there's a line 4 minus 6. Okay, so I can see 2 intersections, so we're good there. So then we're going to calculate those. So we're going to calculate second trace an intersection, and first curve, yes. Second curve, yes. Sure, that's my guess. But again, it's going to, so the first intersection is at x equals 0.25. So one fraction or one solution to this is the fraction 1/4 or 0.25. Okay, then to find the second one, I'm going to calculate the intersection again. First curve, yes. Second curve, yes. And then I'm going to, for my guess, I'm going to go closer to this other intersection, farther away from the other one, and my second solution I see is x equals 3. So we have, for this one, x equals 1/4 and 3, and hopefully that's what we find when we do these algebraically. So in the next video, we're going to talk about how to solve these equations algebraically.